Okay, today I'm going to be doing some problems in logic, and these will be questions of logic, truth tables, the notion of tautology, contradiction, the notion of logical equivalence, the laws of logical equivalences. But before we begin, we should talk a little bit about logical symbols. Okay, so the first one is and. Then we have or. I'm highlighting these here. Then exclusive or. So exclusive or means A or B, but not both. And then this is not. This is logical equivalence. This is implies, and this is A implies B and B implies A. So in other words, if and only if. Okay, so let's have a look at these problems. And incidentally, I am working in Mathematica. So this is a Mathematica notebook, and I'll occasionally write some code as I go along in Mathematica. Okay, so that's what we'll do today. So the first question, suppose you know that bracket, not P and Q, end bracket, or P is false. What do you know about the truth table, the truth values of the variables? Okay, so if we have an or being false, then both of the things, this one in brackets and the P, have to both be false. So let's say both are false. And so we'll reiterate this now. So that says that this one on the left is false, and I'll abbreviate that just by putting equals F. And then we also have P is false. So I'll put P equals F2. Okay, so now we already know that the value of P, it's false. But what about Q? Right, so we know that not P has to be true. Okay, and if not P is true, but this entire thing, not P and Q, is false, then that means that Q has to be false. So Q is false. Okay, and to summarize, what we have then is P, Q is false, false. All right, great. So let's move on to the next one. Suppose you know that P or Q and not R is true. What are the truth values of the variables? All right, so if that's true, then both of these things in brackets have to be true. So we'll say then this is true, and not R is true as well. Okay, so that then means that R has to be false, right? So R is false. But now we have a few possibilities for P and Q, right? They could take on a number of possibilities, right? So basically what you cannot have is both of those being false. So let's just note that. Cannot have P, Q both false. Okay, and so let's have a look at the cases that we can have. All right, so I'll write these as triples, P, Q, and R. Let's say it's equal to, now in each case we've deduced that R has to be false, but for P and Q we just know that they cannot both be false. So we can have TT F. Let's see, I want to copy this, paste. We could have T, F, F. We could have F, F, F. All right, so these are our possibilities. So let's say instead could be. All right. Okay, good. So let's continue on to the next one. Now, incidentally, I'm in Mathematica, but I can see that some of these are black rather than bright blue when I write them down. Okay, so that tells me that I've got a few things in memory. Like, for example, you see the P being blue, but the Q is black. So what I'll do is I'll go evaluation, and then I'll go quit kernel, which is right here, local, quit. Okay, great. And then just in case I want to do a calculation, I'll go 1 plus 2. It'll take a little bit of time to run the kernel again, but once it does that, it'll be fast from there on, until I need to quit the kernel again. Okay, so there it gives 3, and so let's calculate that. 1 plus 2 is 3. All right, great. So let's move on to the next question. This is a different one. I see I've written B there, but it should probably be C. Okay, good. So now, suppose that this in brackets and R is false. What are the truth values of the variables? All right, so we have an and here, but it's false. So we just know that we cannot have false and false, right? So that's going to give us a number of possibilities. So we need to consider some cases, right? So case 1, if R is true, then since the whole thing is false and there's an and there, we know that the other one has to be false, right? So this other one is false. Okay, but there's an and there, so we can't have both of the things on either side of the and being true. All right, so from this we get several cases. We could have then, let's just list these, P, Q, R could be. Let's see, we can't have true and true for not P and not Q. So that would be false, false for P and Q. So we want everything but false, false there. And the last thing's true, right? Okay, so we could have true, true, true. We could have true, false, true. We could have false, true, and true. And that exhausts those possibilities for when R is true. All right, now our other case is when R is false. So if R is equal to F, then well, in this case, this one could be true or false, right? So there are a number of possibilities in this case. In fact, all of the possibilities for P and Q. So what we'll get here is true, true, false, true, false, and false, false, true, and false, or false, false, false. All right, and I should write PQR could be. So we basically have 7 possibilities in total. So let's just write 7 possibilities in total, which are essentially all except for one of them. And the one that we can't have is, so cannot have false, false, true. Okay, great. So that one's done. Let's move on and have a look at question 2, which is about a truth table. So it says, for each of the following, write a truth table and determine whether the statement is a tautology, a contradiction, or neither. So I should define what a tautology is and a contradiction is for you. A tautology is if it's always true for all of the cases, and a contradiction if it's always false for all of the cases, and neither is if it's neither a tautology nor a contradiction. Okay, so first thing we should discuss is how to fill out a truth table in a consistent way, because if you don't do it in a consistent way, it's kind of hard to check, or just more. You've got to spend more time checking. Okay, so what you want to do is with the one on the right, so you put these in alphabetical order, right? The P, the Q, the R, or the A, B, C, or whatever you have. Put those in alphabetical order. Take the one on the right hand side and just alternate. So we put T, F, T, F, T, F, T, and F. Okay, then we go to the one on the left of that and we put T, T, F, F, T, T, F, and F. All right, finally, the one on the far left, which is the P, we'll put 4 T's followed by 4 F's. So T, 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 then F, 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 and F. All right, so now we can consider all the so these are the cases. We've got 8 cases. Incidentally, that's 2 to the power of 3 equal to 8, and you could do this with ones and zeros, where you do it in binary and you'd count from 0 to 8 minus 1, which is 7 in binary, and then you'd list those from bottom to top. And if I remember right, that should be in, I think, reverse order, but anyway, you can work that out. Okay, so what I've done to build this truth table is I've opened a palette and inserted, so I've got insert, table matrix, and then I could go new, and then I would put a table or a matrix, right? Probably a table, and then you could click draw lines between rows, draw lines between columns, draw the frame, and so on, right? And then you've got to carefully choose how many rows and columns you want. I won't do that because I've already done it here. Okay, but what you could do basically in this column here where the P is, you could go and copy what you have here, right? And likewise where the Q is, you could copy the values for the Q, that column there, and put them here. All right, but I find that if you do too many things, it gets a little confusing to look at. So what I'll do instead is I'll just work out what the value of P and Q is, and I'll fill in that column. Okay, now I typically take my fingers and I put them on the page or over the screen just under the P and Q and go down in the rows so I can evaluate this carefully. All right, but I'll just say it aloud. So T and T, that's true. Okay, so next we have true. Next we have false, because T and F is F. Again, F. Again, F. F and T is F. F and T is F. F and F is F. And F and F is F. All right, next I would go and do the Q and the R. So again, I'm taking my fingers, placing them under the Q and the R and going down row by row, but I'll fill in the column that's under the and. Okay, so T and T, that's T. Then we have T and F is F. F and T is F. F and F is F. T and T is T. T and F is F. F and T is F. F and F is F. All right, good. So now I've got a bracket. I've got to do this or this, and then there's a bracket around that. So next I will fill in what's under the or. So this time I'm taking my fingers and I'm placing them these two under the two ands right here. So I'll highlight that and this and then I'll evaluate an or between those. So T or T is T, T or F is T, F or F is F, F or F is F, F or T is T, F or F is F, again F, and again F. All right, good. I think that's correct. It's easy to get these wrong, right? Because you kind of can go into a mode like you're a factory worker and kind of think about your weekend or something. So you've got to be careful. All right, now what I typically do here, once I've done some major piece of the puzzle, underneath that I would go and put an asterisk or something, right? Now it's a bit hard to do from this point of view, but on paper it's really easy. So, but what I'll do is I'll just put an asterisk there, okay? Because what I would do here is I do the same once I've filled out the part for not Q, and then I'd put an asterisk under that column. So it would be really easy for me to take my two fingers and put it under those columns where the asterisks are, so that I could fill in the final column where the or is. Okay, so now what I want to do is take the value of Q and turn true into a false and false into a true, so I can evaluate the not. All right, so I'm looking at the Q column. This time, since it's so far away, I will actually just copy and paste that into this column for the Q right here. Then now it's close, and so I can just fill it out nearby. Okay, so I'm turning these into the opposite value. All right, good. And now I want to put an asterisk below that so that I can compare the final two columns with an or. All right, so I'll take my fingers, I'll highlight what I'm looking at here. So T or F is T, and we come down, T or F is T, F or T is T, F or T is T, T or F is T, F or F is F, F or T is T, F or T is T. All right, great. Now let me check, see if I've done this correctly, and I think I have. All right, so we don't quite have a tautology, do we? Because there are not T's everywhere down this column, and that's the final column. We have a single F right there. So this is neither a tautology nor a contradiction. All right, great. Let's move on to the next one. Again, we'll fill out a truth table. Okay, let's give this some space so we don't get confused looking at all of the other stuff. All right, so question 2. Here we've got something with an or. So not P or Q, and then an or P and not Q. All right, and we've got to make a truth table for this. So again, we take in alphabetical order with PQ, we start Q, T, F, T, F, and then we come over here with P on the left of that, and we have T, T, F, F. Okay, great. So we start to fill out the truth table now. Okay, so here I've got a column for not P, just to simplify this a little bit. All right, so then I just want to flip the trues into false and the false into true. So this would be F, F, and T, T. All right, great. So now next I've got to apply this column and Q to work out the next one, which is what I'm highlighting here. All right, but the Q is nearby, so I can just look at these two columns together, thinking of an and, right? So the only place that's true is the third row, so I'll just put a T there, and then I can fill out F's everywhere else in that column. All right, good. So I think that will require us to put an asterisk below that because that's the second last. All right, next we want not Q. So I'll go ahead and fill out what not Q is. We alternate FT, whoops, FT, FT. All right, now P is a bit far away, so I'll copy and paste P and I'll put it here. And then now we can evaluate the and between these two columns. Okay, so it's only true in the second row there, so it's false everywhere else. A false, and a false, another false. All right, good. And so we now need an asterisk below that so that we can compare the two columns that have an asterisk, and we have an or between those two, right? Okay, so it's false when we have two false. So the first one's false, and it looks like the last one is also false, but we have true in the middle too. All right, great. So we've now filled in that truth table. And let's go ahead and move on to the next question. Okay, so the next one says use a truth table to show that these two things are logically equivalent. All right. Now it should be in the same cell, so I'm going to go ahead and copy this and put it in the same cell. And what I like to do is I like to keep the same problem in the same cell, because when you later want to do a calculation, for example, if for some reason I wanted to do a Mathematica calculation in this cell about this problem, it would just look simpler, you know. For example, let's just talk about an or in Mathematica. So I could put true, and then an or in Mathematica is a double vertical line, true or false, and then I'll press shift and enter and I'll get true, right? But typically when you write logic in mathematics, or you read a book that's got logic, this V shape would be the or. So I'll stick with that when I'm typing this. Okay, so again, we want to fill out the truth table for P and Q in the same way. So I can just copy this from this place, paste it here. All right, great. And then I want to apply an or between P and Q. So we have true, 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 and then false there. Then the next part of it here is a not P. Should probably have a bracket around that. Okay, so not P, it's the opposite of P. So we have false, false, true, true. And then this last one here. Oh, hang on. No, we want to do this and first, right? Because this is on the left of this logical equivalence sign. So we need to do this one, this column next. And to do that, we just apply an and to these two columns. All right, so the only place that's true is the third row. So it's false everywhere else. And then I believe I want an asterisk under that, so I can compare it with this, which will indicate this entire piece. Okay, so not P, that will be F. F, true, true. And then Q, I will just copy and paste that because it's a little far away again. Now we want an and between these, right? But the only place this is true is when they're both true in the third row and false elsewhere. Okay, and I want an asterisk there. All right, so now do we have the same in each of these columns? And yes, we do. Right, so actually what I need here in the truth table is this symbol, right? Because if you deduce that they are logically equivalent, then you just put this, and that's what that means, right? So what we want here is the if and only if. All right, now we're evaluating whether we have the same thing in each of these columns. All right, and so you can see that we do. This column is the same as this column, so we put a T down that column. Okay, and since we have a T in that final column, so come back to a comment here. So we'll say since final column under the if and only if symbol has only true, we have shown that these two things are logically equivalent. All right, great. So let's move on to question 3b. All right, this one says use the truth table to show that these two things are logically equivalent. Okay, now I'll remind myself what I need to do is put the if and only if symbol here. Okay, great. And we hope to get all trues down that last column. All right, and we're dealing with exclusive ors there. So in other words, like you can have tea or coffee on a flight, but you can't have both at the same time. You know, when the stewardess or steward comes along, asked you, would you like tea or coffee? Yeah, I'll have both, thanks. No, you can have one. All right, so look, we've got a PQR there, so that's 8 things. I wonder if I can copy and paste from a previous collection of columns like this one. That'll be good. Let's copy and paste, and we'll put it right here. Okay, good. Now, let's go ahead and do this column first, the exclusive OR. So we're looking at the P and the Q column. So let's just identify where we have this being true. So this middle segment, and it's false elsewhere, because up above here we've got a true and a true, which is false. So this right here, these are all false. Or sorry, all true. So true, 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 false, false, and then a false down the bottom. Okay, good. And then the R is a little far away, so I'll copy and paste that, and we'll put it right there, so that we can now evaluate this and this column. Okay, so let's look for where this is true. So we've got a true here. We have a true here. And I don't think anywhere else there, so we'll just put a false for the rest of those. All right, then we'll move on. Actually, we'll put an asterisk below this, because that's the left-hand side of this symbol. And then let's just put something here, and this will be our asterisk. Okay, and we'll fill this out later. All right, but now we'll do the P and R, so this column right here. So P and R. All right, so that's an and. So let's identify where it's true. So the first one, and then the third one, and I think that's it. So the false goes everywhere else. Okay, great. Now let's do Q and R. So we've got a true way down here in the 5th row and a true up at the top row. Pretty sure it should be false everywhere else. False, 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 false. Okay, great. And now we need to do an exclusive OR between these two columns. So let's find where we have it true. So true here, and then false everywhere else. False, 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 and false. Okay, great. So now we can focus on the two columns with the asterisks under the columns. And our question is, are those two columns the same? So I'll use my fingers and go down row by row. So yes, 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 and yes. So they're all true because they're the same. Okay, so this one is a tautology. So we have a tautology, hence these two things are logically equivalent, meaning this one on the left has the same truth values as this one on the right. And we can replace one with the other if we're using the laws of logical equivalence to simplify an expression, a logical expression. All right, so let's go ahead and have a look at 3C, which says use the laws of logical equivalence and this identity here on exclusive OR to show that P exclusive OR Q and R is logically equivalent to P and R exclusive OR Q and R. Okay, so what we need to do in this one is make some replacements. So you might find that you start with one side of it and then you get so far, right? So, and then you find that you need to work on the other side of it. So I think that'll happen to us here. So let's start with the left-hand side of this expression. This is what we're trying to say something about, right? So this, and then I'll start to make replacements, right? So what we'll do is we'll use this right here, which we're permitted to use, right? So we can assume this. So I'll copy and paste that. So this is equivalent to, in brackets, all of this and R. Okay, so next, you might think, well, maybe I want to use De Morgan's law on this, right? That might be natural. So you could come down and make another replacement, and you would say something like, using De Morgan's law, we would put the not inside here and here, and then we would turn the and into an or. Right. So exactly like that. And then you might say, well, what do I do now, right? You've got a number of other rules, and so what I'll do is I'll pull up my lookup book. Sometimes I call this my lookup book, but I've been talking about this as called a YouTube course in Mathematica. Basically contains a whole lot of hints on a lot of early maths topics that you might learn. Okay, so here we've got De Morgan's law, and I probably should have used the logical equivalence symbol here rather than the if and only if symbol here. But I mean logical equivalence where I see that. Okay, so then here are a number of other laws in addition to De Morgan's law. Basically that all these things have the same truth values, right? And so we can make those as replacements. All right, but we get up to this point and wonder, hey, how does it look compared to this one that we're trying to show that that's the same as, right? So you might just start to work on the right-hand side. And so we'll just put a full stop there and start to work on the right-hand side. All right, and so we've got an exclusive OR here. Whoops, I want the other symbol. I want this one. We have an exclusive OR here, and we may as well go ahead and use this definition here of the exclusive OR. All right, now it's a little bit tricky to do, so what I'll do is I'll copy this, and I'll put an X and a Y there, right? Just so I don't confuse it with the P and the Q. Okay, but I want to say X is this one on the left and Y is this other one. So now you can see why I did that. So I want to go ahead and copy and paste. Take this and paste everywhere I see an X. Paste it there. Likewise, this one will be the Y, and I'll paste it where I see the Y. And now I've got the correct replacement for this, given this rule up here. Okay, great. So next, what I want to do with this is, let's see, what do we have here? So we've got a lot of ands, right? We've got this, and this, and this. And so we can use the associative rule, right? And basically just take off the brackets. So I'll leave that over there. Okay, so we'll take off the brackets here because we can do that by the associative rule. And you see we've got all ands. Now by the commutative rule, we can make this one commute over to the right, put it next to the R, and you can see that R and R is just R, right? So we'll just get rid of one of the and R's. Okay, good. Now what we want to do next is let's try to simplify this a little bit, because we can simplify this piece on the left here using the distributive law. Okay, so that'll be where I've got my mouse on the right hand side of the page, just hovering next to the thing that I want to use. Now they're named different letters, so I've got to be careful in how I apply this. All right, but I want to sort of factorize out the R. Yeah, and then okay, so I'll just do this. I could be wrong. It's a lot to look at, so copy and paste this because then I can just change some things. So I want to factorize the R. I'll factorize it to the right. So I want to put it, or sorry, to the left. I want to put it here. But let's see, what we'll get here is R and, so I need an and symbol. P or Q. So then if I distribute it back over, I'll get what I meant to, which is this one. Right? So this is acting just like if you distribute some algebraic expression, multiplication over addition, for example. Okay, good. Now, okay, so what I want to do next is put some brackets around the P and the Q here. All right, so let's just do this on this line. So that now I can apply De Morgan's law on this. All right, so I'll copy and paste this, and then I'll just use De Morgan's law. So putting the not inside there, and I've got to change this and into an or. And then we'll get rid of that. Okay, and we still need the bracket around that. Okay, this is a little tricky, right? So next what I want to do is move the R over next to this so that I can use the distributive law the other way. So let's go ahead and do that too. So I'll put it there, and I'll need the and sign as well. Okay, and I want to view that like this, with a bracket around this, just to emphasize that that's what I plan to do next, is distribute over. And the reason to do that is because I have a not r there, right? So hopefully we can simplify that somewhat by doing that. Okay, so I'll copy and paste this. And I think I'm on the right track here because the P or the Q matches what we've got here, right? Okay, so now let's make that, well, we can distribute now. So that means that I want to take this with the not, P and Q, and then I have a R and not R there. All right. I think I have too many brackets now. All right, good. And this does look like this one, right? So I think we're on the right track. Okay, now finally, we need to notice that the R and not R, that's just a false, right? So if R is true, then not R is false, and so that true and false is false. But doesn't matter so much because we have an or there. Okay, so let's just note this, and I'll just replace that with an F. And so we'll just say that since we have an or F, that doesn't affect this, and so we can just delete that. All right, and so now we can see that we actually have this one. So our last line, since it's so similar to that, we'll just put that it's the same as this, which is what we were aiming for. Okay, great. Now that was pretty tedious and say kind of hard. Hopefully not too bad for you. So I'll save that now. And let's scroll down and have a look at the next question. All right, so question 4a says, use the laws of logical equivalence to show that P and Q is logically equivalent to not, bracket, not P or Q. Okay, well this one is really simple. Let's start with a more complicated case, or side. So this is the same as, by De Morgan's law, not P and not Q. So I'll just copy and paste this. But we have double negatives here, right? And so double negatives give you a positive. So that's the same as P and Q. So logically equivalent to P and Q there. Okay, too easy. All right, let's have a look at the next one. Use the laws of logical equivalence to show that this great thing on the left is the same as not P. Okay, so let's tackle that side because it's the more involved side. Okay, so this is logically equivalent to, now let's see, what do we want to do with that? De Morgan's law seems natural on the left one because then we can probably use the distributive law. So let's go ahead and do that. All right, so we'll apply the not inside this, and then we'll have a not there. And then I can get rid of the not there, okay. All right, great. So in the next line, the not Q is a Q. So that's a single Q right there. All right, good. And now I want to use the distributive law to factorize out the not P out of the expression. So I'll just take this and I'll put it out in the front to start with. And the reason I'm doing that is because I'm aiming for a not P, right? So it seems natural to do that. So when I factorize that out, let's see, this is always a little bit tricky. I want not P and Q there, right? Yeah, I want an and right here. Okay, so I need to borrow one. And then I have a Q and, or a Q or a not Q. Okay, which is, so if Q is true, then not Q is false. All right, if Q is false, then not Q is true. So when you have an or between these, it's always true. So I'll say that this is that and true. Okay, now since we have an and between this one and the T, that's only true when this is true, and it's false when this is false. So essentially, the truth value of this depends on not P alone, right? So this is the same as not P. All right, good. Okay, so that's we've shown that those are logically equivalent now. All right, great. Now, next one, question 5. For each of the following, use De Morgan's laws to write an equivalent sentence. Okay, so it's not true that I'm studying computer science and I'm studying engineering. Okay, so basically, let's write this in logic. So we have a not, and then we have something in brackets, right? And let's put a CS for computer science, and then we need an and I'll put a ENG for engineering. All right, but it's clear that we can use De Morgan's law on this. So this is logically equivalent to not computer science or not engineering. All right, and now what we need to do is translate this back into English. So this should say, I am not studying computer science. Nor am I studying engineering. Okay, great. And if you're wondering why the I is black while everything else is blue, it's because in Mathematica, uppercase I is reserved for the square root of -1. All right, so I'll just show you. I squared. Right, shift enter, and I get -1 there. But of course, all I'm doing is typing here, right? For the most part. All right, so let's have a look at question 5b. So what do we want to do? The same thing. Use De Morgan's laws to write an equivalent sentence. So I'm not going to the movies this weekend, or I am not going to swimming this weekend. Okay, so we'll just put an M for movies. So that's not movies or not swimming. All right, by De Morgan's law, we can just pull the not out the front, put a bracket, so we have movies and swimming. Okay, great. So now we need to translate this back into English. Let's say something like, it is not so that I am going to the movies and going to swimming this weekend. Okay, and turn this into a comment. Sometimes they don't because it's brighter. For example, up here, it's brighter in colors just for the sake of typing, right? But it's a comment, and so let's go ahead and put a comment around that so that I could then say, do some mathematics in the same cell. For example, expand x plus y all squared, right? If I needed to do that. Okay, good. So that brings us to question 6. For each of the following, write down a truth table for the statement and determine whether the statement is a tautology, a contradiction, or neither. Okay, good. So again, we start with a Q and write TF, and then with the P we have T, F, and F. Okay, so not P is just F, T, and T. And then let's go ahead and do not Q. So not Q will be F, T, F, and T. Now P implies Q. That's only false when you have a T followed by an F, right? So T implies F is false. This is the false case. The rest are true. All right, so now we can evaluate this column together with this column where we have an and. So we've got T and T there. So those are true, and false here and false here. Okay, and now we want an asterisk below that so that we can compare this with this last one here. All right, again, we're looking for a T implies F here. So I see it with this, and so that is false, right? And everywhere else should be true. Yeah, true. T, T, and T. Okay, so the question is this a contradiction, a tautology, or neither? So, whoops, what have I done? So in this case, it's neither. Neither contradiction nor tautology. Alrighty, good. Now let's have a look at the next one, 6b. Alright, so we've got to fill out something with an if and only if there. And we have also a couple of implies. All right, so I need to scroll down because that's a pain to fill out that. So I'll copy it from somewhere. Let's have a look. This looks fine. Copy this one and we'll come down and paste it. There, good. Okay, so we want Q and R first. Let's see, it's true for the first 3 rows. Then we have a false, then we have true, 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 and false. And I put it in the wrong place, haven't I? So I'll scoot that over. Think that's okay now, good. Yep, okay. Now, I want the P here, so I'll copy and paste that underneath this P so that I can more easily look for that T implies F. Okay, so here's 1, so that's false. And so it's true everywhere else. Okay, so that takes care of this bracket on the left there. Okay, so now what we want to do is P and not Q. All right, so I've not been very generous there with the columns, so we'll have to try our best. So P and not Q, well, these are close to each other, so so I want a true for the P to get a true, and I want a false for the Q, right? So these two should be the true ones. And and false everywhere else. So false, 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 and false. Okay, R is a little far away, so let's copy and paste that. All right, so finally we have an implies here. So we're looking for a T implies F. Only right here, so that's false. True everywhere else. Okay, great, and I think we need an asterisk around this, below that now, sorry. And then this one here should also have an asterisk below it, so that we can compare these two now, the two columns with the asterisks in them. All right, so do they have the same truth values now? So yes, 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 and yes. All right, so we put T down the entire column. This is a tautology, and so we just say so, right? This is a tautology. Whoops. Great, and I'll save this because it's a hot day. You know, the computer could overheat here in Queensland, and so yeah, I want to avoid that. All right, write the following statements in the form if, comma, then. Okay, a sufficient condition for the warranty to be good is that you bought the computer less than a year ago. Okay, so we need if blah, 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 comma, then blah, blah, blah. Okay, so basically if you bought the computer less than a year ago, comma, then the warranty, that says to be good, so I'll change that. Then the warranty, oops, will be good. Okay, good. Let's have a look at the next one. Jane gets sick whenever she is on a boat. So if Jane is on a boat, then Jane gets seasick. Great. Too easy. Okay, so the next one is negate the following. So to negate, you need to basically apply a not to it. Now let's abbreviate this first. So I think I can just put a tilde here. So the negation, let's say, we'll write the original one first. So if it rains, so that's rain, R for rain implies, Sue takes the umbrella, so let's put a U for that, right? Now the negation of this would have us just put a tilde in front of this. And you can see here that Mathematica thinks that I'm writing some code, but I'm not. That's okay though, I'm not going to press Shift and Enter. All right, so what we need to do now is use some logical equivalences to replace the R implies U, and then simplify this and turn it back into English. All right, so now I need an equivalent symbol. So look for that. Here we go. Come back down, paste that. Okay, so what I want to look for is to replace the implies. So here we have this P implies Q is the same as not P or Q. All right, so then we have not something in brackets, and so we put a not in front of the first letter, which is R, and then we have or, so I need an or. Here we go. And that's or U. Great, and now it seems that I can easily use De Morgan's law and apply that not inside. So not R, and then not U, but I've got to turn this V shape into an and. So here we go. All right, great. And then we want to simplify this. So this is not on R, it's just R. So that's the same as R and not U. Okay, so now we need to translate to English again. So it would say it rains and Sue doesn't take her umbrella. Okay, good. Next one and last one. The cakes burn if the oven temperature is too high. We've got to negate this, all right? So let's use the original here is H for high implies B for burn, okay? Now the negation, it looks something like this. So I'll just copy and paste this and change the letters. So we have H there, B there, and then H there and B there. And then we just use De Morgan's law on this. Okay, and so that's a not H, not B, and then we need this to be an and. Okay, so this is the same as H and not B. And now we need to write this in English. So the oven temperature is too high and the cakes don't burn. Great. I'll save that. And that's all I have for now. Okay, so thanks for watching. I'll have several other videos on logic to show you coming up. Okay, so bye for now.